Okay, today we're going to build a 3D printed version of the 1950s Flashy Jim, aka R7 robot. And I'll put links to the videos of the actual toy operating down below in case you're not familiar with it. But what's unique about it is that it was a pin walking toy, meaning there's a bell crank simple linkage that moves up and down and forward and backward. But what they added to it, because most pin walking toys have stationary legs, and the pin underneath the legs is what moves to make it. They added moving legs to the pin walking action. So they added dual functions to it. Initially I was just going to use up all this, well, in fact I did, use up all the different colored scraps of filament that I've been saving for the last 7 years and just paint the whole project. But I started with the feet, and once I started painting I realized what a pain in the butt it is to paint and how crappy I am at it. And it's too cold because it's still winter to do any spraying or painting outside or anything. So I scrapped the idea and decided it's just going to end up being a multicolor type thing. Now I should have started by having this, at least this one leg apart, so you could see how this gets assembled. So I'm going to take this apart like so. So these are the first parts I printed. As a foot, and it prints just as you see like this on your printer. No supports necessary. The holes will be there. Again, for all the axles and rods that I'm using in this is a 1/8 inch American welding rod, so it's basically 3mm, just a smidgen over 3mm for the rest of you. There's an outer leg piece that you print. It prints laying on its side, and you will need supports obviously for these parts here and for here. Not for the middle though, your printer can bridge that. So I just use the Prusa slicer, so you can put in either support blocker or support indicator where you want them, either way. I just put the blocker in, and basically where my 2 fingers are I said block that out and put supports everywhere else. So that way I wasn't trying to dig out supports through this whole hollow part of the leg, because this needs to be smooth when you're done. And in fact, it's not a bad idea when you get done to take a flat file and just run it through there and get any little burrs or anything that might be in there out. The rod, as I already told you, it's about 3mm, 1/8 inch. It's about 1 inch long, and it's going to go into the hole and into the hole in the bottom of the leg. Kind of see it going through there, go through both sides, and this can stick out. Now what I decided to hold my rods in place was just to take, this is a very small piece of silicone rubber tubing. Just took a razor blade and sliced me off a whole bunch of little pieces of it, because it'll fit very snugly onto this shaft, and then I don't have to worry about the shafts coming off. And it won't go anywhere. Silicone is not going to deteriorate. Then there's a rear linkage piece, and of course it prints flat on the printer, no supports required. And it doesn't matter if you run it up from the bottom or run it up from the top, but basically we're going to put a pin on that. Like so. It pushes all the way through. And again, I'll just put some of this silicone rubber tubing on there. That holds those in place. So now you have something that looks like this. There is the pin walker. This is the one that actually does the movement. And this part will be towards the front of the robot, which will be towards the knee section of the robot. And this is optional. On the very end here, I designed it so that I could take a small rubber O-ring and pop it in the very end, the part that's going to be touching the walking surface. So if I'm walking this on something that's really slick, like linoleum or glass, like out in the Robothut where I'm always demoing them, this will give a little bit of rubber traction to help the pin do its job. It's not necessary. Works just fine, or works almost the same with it or without it. But there you have that. So that's one leg assembly. I'm going to move on to the motor part now. This motor frame prints this way, no supports required. And if you've watched my other videos, this is a TT gear motor. This is the 48-to-1, the faster version. Drops straight down. There is a little hole in the bottom, which will be marked when you print it, that you do have to cut that hole out with an X-Acto knife or something so that this end of the motor can poke through. And these are 632 screws. You'll have to figure out what that would be in your land, but the point is they thread into the motor. They just happen to fit perfectly. So that's what I use to hold it in 4 places. This is a cam that prints this way, no supports required. You clean the D slot out on it, and then you can slide that, and there'll be one of those on either side, but you want to make sure that you offset them 180 degrees. So if this one's facing forward, then this one would be facing back, so that you can get the camming action. Now this little circuit board in the front, this is because I'm adding LED lights to it. You certainly don't have to, but I did. So this is just a step-up voltage regulator. It'll take anything above a 0.5 volt and boost it up to 5 volts. And that's just where I happened to put it. I could have shoved it in the head of the robot, but I had a little space there, and I went, what the heck, I'll put it there. I took a normal AA battery holder because I had some laying around. This is plenty big. If you want to 3D print your own battery holder to put in there, feel free to do so. I just had that. No reason not to use it. Glued it in there. Same little switch that I use in all my projects. It's about 19.2 millimeters from screw hole to screw hole. It's a number 2 machine screw. And just interrupt one of the battery wires with it so that you can turn the motor on and off. So you can see that they should be concentric, in case you didn't understand. And power is getting to the little step-up unit as well. Okay, maybe we should take a look at, in case you guys don't really understand pin walking or linkage walking or what you want. Again, for the axles, for holding the leg on, I'm using some more of the 1/8 inch welding rod. But for this little demo, I thought I would just hold this on here. See, there has to be a point. So this action down here, as you can see, it not only goes forward and backward, but it goes up and down, if I can kind of give you a reference to look at. And that scooping action is what's going to make the toy walk. Now when you're setting these things, the offset of your cam, it could just be a bell crank, a piece of metal bent with a crank in it, or it can be a cam. Either way, it doesn't matter. How much of an offset you have there is going to determine how much lift this has. Now, how much forward and backward you have is going to be determined by where this pivot point is. So if I moved this rod up closer to this disc, you could get a lot more throw. You could walk a lot further, but you wouldn't be changing the lifting and lowering part, because that's set here. And I basically had to set this at a very minimal amount of walking, which the original toy had, so that it would fit within the size of the foot that I was making. I guess we can put one on there. I don't know why not. If it's wrong, we'll take it off and we'll start back. So you're going to start by inserting this in like that. And take that rod out of there. And you kind of have to get the hoops all lined up like so. Then this longer rod, this is about 2.5 inches long, because it's not only going to hold the legs on, but it's going to hold the body on in the end. But for right now, we're going to just use it to hold the legs on. So I've pinned the front of the leg through the holes in the body. I'm going to take that rear cam. I'm only doing this to show you what it looks like, because like I say, to put the body on, we have to take these rods out. And then the shorter one, this is 2 inches as I recall. So that gives us our points of articulation, if you will. So now you can see we have the leg action and you have that little cam action. And that's what's going to give you your walking motion. The same thing, of course, would be applied to this side. We'd put this leg on. Well, in fact, why not? Let's just do it. I'll probably end up dropping these rods on the floor, but you'll get the idea. Because it's a good idea to test this mechanism before you assemble it all the way. The only way you're going to test it is to assemble it. Here we go. Getting there. Have to get that rod lined up and get the linkage lined up. There we go. Dang, told you I'd end up dropping one of those. There's nothing to hold them in place until you get the toy put together. This is the pivot rod I'm talking about. It's the shorter of all of them. So, when you get them all in place, then you should be able to have it start walking like that. So then the next part in this was to print the body. The head is a separate part, but I already have it glued on. The body prints in this position like this, and you will have to have supports between here and this little bottom piece and here and this bottom piece, and I ran supports up to the bottom of the arms, but I don't run any supports up on the inside, so it prints like that. So once you get it off, you have to remove all those support material from the outside and from the bottom here, and then the hole up in the neck, you cut that out the rest of the way. I left a very thin layer there with an X-Acto knife because the motor, end of the motor, is actually going to poke up into that hole, and we're going to be running some, well, I ran some wires for the lights up there as well. When it comes off the printer, there's going to be a slight buildup right here and right here. So I took a flat file and just ran it back and forth and smoothed all of that out of there. Okay, the back of the head, as you can see, is here. Prints flat, no supports. So we pull these rods out. Except for the pivot rod, it can stay, if it will. Then, having these extra wires isn't going to make it any easier on me, but basically, you're going to slip the body down over this whole thing. I got to try to get those wires up through that neck hole. Like so. This has to go all the way down like that. Then you should be able to look in through the sides and see the leg hole. Get that started, and then see the bottom part of the frame. And if it's not pushed up all the way into place, you won't get that one to go in. I'm trying to hold this in a way that the camera can see some of what's going on, but that isn't making it any easier for me. I may have to give up on that idea. Yeah, I've only done this about 1,000,000 times. I wonder why I can't do it right now. I'm going to go ahead and connect the rear. I think it's just not quite down all the way. Yeah, there we go. Got that one. There we go. Just didn't quite have it pushed down all the way. So now we've made it through the legs, we made it through both bodies. Trying to line up this rear linkage. I know you can't see what I'm seeing. That's okay. So I've pushed the rods in all the way through, and in fact you can see the rods down in there. And if you want to make sure the rods don't ever fall out, you could take a little bit of glue and just dab, because the rods don't rotate, they're just there to pin everything. So now you can see how this is all pinned together, brought together. I have some wires to connect here for the lights, because I have LEDs in the eyes, and I have multicolor RGB lights in the chest. So what I need to do, heat up that soldering gun while I'm doing this. I have to put my readers on. I can't see what I'm doing. That's better. At least now I can see the wire. Okay, there's that. Take a little bit of solder. Okay, I think they're soldered. So let's test things now. This is a dollar store battery. This thing doesn't draw hardly anything. 1.5 volt. Okay, so we got the green eyes. We got, I need my camera up a little higher, don't I? You can see I've got all the multicolor stuff going on in the chest. We got it walking, it's pin walking. Uh-oh. Just realized what we screwed up. Before we put the body on, we should have inserted the arm axles and the arms. Holy guacamole. You know, it's always something. If only I'd have remembered that before I soldered these, it wouldn't be so bad. Hopefully I'm unsoldering the right two. If I'm not, then it won't pull off the body. So I guess we'll find out. Okay, take that. And after all that fussing, fighting to getting those two rods in place, we now have to pull them. That's okay. Pull those. See if I unsoldered the right two wires. There we go. Try to keep this thing here sitting there. Alright, let's step back. I've got this leg arm linkage, and they're basically just going to sit inside the hole like so. And my screwdriver here. Let's get this one apart. I had them screwed together so I wouldn't lose the parts. So this piece prints flat like that, no support. And the arms actually print in two pieces. You can see a seam. Both print flat, but I glue them together to give it a little bit more girth. Looks better that way. Okay, then I'm using a tapping number 2 screw to screw the arm onto that piece. And the right adjustment would be when the lever on the inside just hits the top of the body, the elbow should be about in line with the R7 badge on the front. And that'll give it enough gravity so that it can swing well. Let me put the other side on. Like so. Of course you could glue the arms, they don't have to be screwed. So right about there. Okay, so now to assemble a thing, you want to hold it upside down so the arm links are out of the way and won't get bound up on anything. And then you're going to have to take this whole mechanism upside down and insert it like so. Grab your rods again. Like that. Hey, the front one went pretty fast that time, didn't it? And we'll get the rear piece of linkage by moving the foot around like so. Like that. And let's reattach our two wires, if they'll let me. Like that. Try to get the yellow one. I should have left these wires longer because the head's hollow. You could wad up all kinds of wire up in there. Okay, let's see how we did now. Oh, good. It's much better. So we still have all our lights, and now we have the moving arms. So once you're sure that everything is working the way you like it, then of course that's when you would glue the back of the head on for that kind of a look. And if you want to form the little metal piece that goes into the top of the actual toy, you could do that and glue it in place as well. I don't think I'll bore you with the gluing process, but I'll be gluing that head on. And there you have it, your 3D printed Flashy Jim R1 robot.